In today's video, we're going to be talking about derivatives of logarithmic and exponential functions, because we have a few special derivatives for, well, logarithmic and exponential functions, just like trigonometric functions. Let's talk about them now. The first function we're going to talk about is by far the easiest derivative to remember. The derivative of e to the x is just equal to e to the x. Another very commonly used derivative, the derivative of ln of x, or natural log of x, is equal to 1 divided by x. This is another derivative that pops up very often and that you should just have memorized. Besides, it's not a terribly hard one to remember compared to some of the trig functions that we talked about last time, which if you haven't watched that video already, you can check it out here. Now for the slightly more complex derivatives. The derivative of a log function, such as log b to the u of x, with u being a constant, x being x, and b just being whatever base you're working with, this derivative is equal to 1 divided by u times natural log of b times du dx. Essentially, this rule is a very specific version of the chain rule, and if you don't know what the chain rule is, you can check out my video about it here. And the last derivative we're going to talk about in this video is the derivative of some function to the x power, or in this case, u to the x, because we might have a coefficient. This derivative is equal to a to the u times natural log of a, also multiplied by du dx. Just like with our log, this is essentially just a more specific version of the chain rule used for this function specifically. So now that we've established all of our logarithmic and exponential functions, let's do 2 examples today using these to solve these equations. I'm going to erase them from the board here, but I'll leave them up in a screenshot on screen. In our first example, we're going to find the derivative of cosecant 2 to the x. What does this derivative equal? Well, the first thing that's pretty evident with this problem is that we have a function within another function, so we need to use the chain rule to solve this problem. As a reminder, the chain rule, aka d dx of f of g, is equal to f prime with g of x inserted into it times g prime of x. We'll be using this equation to solve this derivative. Okay, first of all, what is f of x? Well, f of x is our outer function, and in this case that is cosecant. So cosecant x. G of x is our inner function, which is 2 to the x power. Now we need to find f prime and g prime of x. The derivative of cosecant x, which we discussed in my last video, which was about the derivatives of trigonometric function, is equal to negative cosecant of x times cotangent of x. And g prime of x is the derivative of 2 to the x. And the derivative of 2 to the x power, based on our exponential rule, is equal to 2 to the x times ln of 2, or natural log. I just say ln more frequently because it's just the shortened version. Now let's apply the chain rule to this problem. Our f prime is negative cosecant, and instead of putting x in here, we need to put g of x, which is 2 to the x, times cotangent of 2 to the x. Just like before, we have to replace our x in here with our g of x function. And then this whole function is multiplied by 2 to the x times natural log of 2. And that is our derivative, using the chain rule along with some exponential function rules. As you can see in calculus, we need to combine a bunch of rules in many problems in order to solve the problem more easily. Knowing your rules, such as log and exponential functions, the chain rule, and in this case especially the rules of trigonometric functions, is highly important, and I highly recommend you study and practice them quite a lot. We're going to do one more example for this video, so let's do that now. In our last example for this video, we need to find the derivative of log base 7 of square root of x. What is this derivative equal to? Now, this problem probably looks pretty intimidating at first, but based on the log rule that we just learned a minute ago, it's not quite as bad as it may seem. So first of all, once again, we have a function within another function, so we need to use the chain rule again. Oh, and I erased the chain rule from earlier, so I'm just going to rewrite it here real quick. Sorry about erasing it earlier, but I put it back here for your convenience. So in order to apply the chain rule, we need to establish our inner and outer function once again. Our inner function, of course, is going to be square root of x, and that will be our g of x, equal to square root of x. And our outer function, f of x, is equal to log base 7 of x. Now, once again, we need to find the primes, or the derivatives, of both these functions in order to plug it into the chain rule over here. So let's do that. The derivative of g of x, aka g prime of x, is the derivative of the square root of x. And remember, the square root of x can be rewritten as x to the 1/2 power. And this makes it much easier to solve because we can just use the power rule on this. So here we need to take this 1/2 to the front and then subtract 1 from our power. So this turns into 1/2 x to the negative 1/2 power. Now for the derivative of f of x, which is f prime of x, we need to find the derivative of log base 7 of x. And just a minute ago, we learned how we can find the derivative of a log function. And the derivative of any log function is equal to 1 divided by, in this case, x, because we have an x within our log, and then times the natural log of this little number right here, which is 7, aka the base we're in, which is base 7. Now we just need to apply the chain rule to this function and solve. So first of all, our f prime is equal to 1 divided by, and now for x, we need to plug in g of x, so this is square root of x, times natural log of 7, and then we need to multiply that by g prime of x. So we need to multiply this by 1 divided by 2 square roots of x. Here's something fun about square roots. If we multiply the square root of something by itself, or in other words, a square root times the square root of the same thing, it just turns into whatever is under the square root. Oh, and I want to mention this just in case this was a bit of confusion for you. Here we have x to the negative 1/2 divided by 2. Anything to the negative exponent can be thrown into the denominator, and the 1/2 power is the same as the square root of x. So we move our x to the negative 1/2 to the bottom, so then it becomes x to the 1/2, which is the same as the square root of x, so we end up with the square root of x on the bottom. That is still being multiplied by 2 on the bottom, and 1 is being divided by both of those. So that's how we got there, just to clear that up. Anyways, back to what I was saying. Anything being multiplied by itself under a square root is just equal to whatever is under the square root. So this function is equal to 1 times 2x. Remember, square root of x times square root of x is just equal to x. And then this 2 is still here, times natural log of 7. And that is our derivative. That wasn't so bad, right? It was a little bit intimidating, I won't lie. Something like a log function just looks a little bit more funky than a normal algebra thing. But once you get the hang of it and get a couple practices in, it's not so bad at all. I hope you guys learned something in this lesson. If you did, consider subscribing. And also, if you want more Calculus 1 lessons, you can check out this entire playlist here of all of my Calc 1 lessons. I know, it's all in one convenient spot. It's awesome. I'll see you guys in the next video.